This is my project. It is about smart soil quality assessment for data-driven fertigation. Here I have 4 samples of different soils collected by using different sensors. It means I have 4 parameters: temperature readings, moisture readings, nitrogen readings, phosphorus readings, and potassium reading. In this project, irrigation, when the irrigation is needed, the valves are actuated. If not, there is no irrigation. And after, the notification will be sent to the farmer via GSM about soil status, which means it's about NPK. So it is in order to decide the amount of fertilizer to be added for the next irrigation cycle. But this is like another part that will be worked on the future project by, as I have given the recommendation by other persons. Even me, I can do it in my PhD or even on the research project on my paper. So it is to check the amount of fertilized needed according to the type of plant the farmer want to plant in the soil. And after that, the data will be collected and sent to the last step is that all this data, after capturing the data in soils, and as my project is focused on to detect if the irrigation is needed or not, and after capturing all data, the data will be collected and sent to the ThinkSpeak Cloud platform for future analytics and research. So for the first sample, this is my first sample. This is a temperature sensor. This one, it is a moisture sensor, and this one, it is NPK sensor. So as you see, this soil for the first sample is very wet, as you see, which means because it is very wet, which means there is less also temperature, so more content, which means there is less temperature, as I have coded in my project. So, and the NPK will give you the values, different values, as you see here. Nitrogen is 10, potassium is 2, soil moisture, phosphorus is 5.3%. So soil temperature is 23.75, and soil moisture is 662. In my codes, in my original codes where I have coded, there is a condition where if as the maximum value for the soil moisture is 125. So if the value is less to, so for this first step, as you see, for these soils are very wet, which means for this step, the first sample, as you see, the soils are very wet and which means in the temperature is very so for this first sample, the soils are very wet, and when you compare it to this second one, as you see, the soil for the first sample, the soils are very wet compared to the second one. As you see, is not wet as you compare to the first one. The third one is dry like a normal soils, And when you compare it to this one, for the last one, this one it is too dry, which means when I will put my sensors on these different cells, will give me different automatically different data, which means for this one it will not irrigate, for this one also, because it is weight, it will not also irrigate. But for this one, as you see, it is dry somehow, which means the valve will automatically irrigate, and for this last one the valves will automatically irrigate. So let's take our data for this one. Okay, so for this one there is no irrigation because our soils are very wet. For the second one, for the second sample, there is our leadings which are capturing data. Soil moisture is changed, and also the temperature is changed, but there is no irrigation. And for the third one, sorry, I have to put this one in this third sample. For the third sample, here I'm collecting the data and picking temperature and soil moisture. And as you see, because here there is less temperature and less water, as you see, the valves are automatically pumping. They are irrigating our soils. This is the tank of water. This one, it is for putting or pushing the water in the pump, and here this is for doing the irrigation. So as compared to those last two samples, as you see, this one was very wet, this was wet, and this one is dry, which means it is like a normal soils. So the valves are automatically pumping. So let's continue. As you see here, the nitrogen, potassium, and phosphorus are changing, and also for temperature and moisture are also changing. And for the last step, as you see, for the last step, for this sample, the NPK is putted, the soil NPK sensor is putted in the soils, and soil moisture is also putted in the soils, and temperature. We are collecting the data, and those soils are too dry. That is why on these valves, the valves are automatically irrigating. Suppose that this is the farm, this is the farm. If we want, we can lift up this pump and then irrigate the water. And for the data collected, the soil moisture is 986, and for the temperature reading is 25.88 degrees Celsius. Thank you. But also the SMS for GSM, for GSM, this is the soil status of NPK. The first value, it is for nitrogen. The second one is for phosphorus, and the last one, it is for potassium. So, and as you see here, our data should be on ThinkSpeak platform. This is how the data are monitored: moisture, temperature, nitrogen, phosphorus, and potassium. As you see, as the hours change, it is how the data, because I have taken different readings, different parameters. As I changed the soils in the sensors in the soil, it is how the data is changed. As you see here, the time